Hi, this is Puneeth. I'm Raju Kucherlapati. Today I'm presenting about the deep learning for the information retrieval. This topic explores how the deep learning is transforming the way machines understanding and retrieve the information. It goes beyond the traditional keyword fetching to achieve this semantic understanding and the meaning. The system can grasp the intent and the context behind our queries. Especially initially, it's a technology that revolutionizing the modern search engines, recommendation systems, and the even conversational AI. And while coming to the what is information retrieval? Information retrieval is an automated process of finding the relevant documents or the data in the response to the user queries. It's the engine behind the every search of your platform perform. And while coming to the traditional IR, the traditional AI system depend heavily on the keyword matching and the ranking algorithms such as BM25 or PF These models look for the exact word overlaps between the query and the documents. They perform well for the simple cases, but struggles when there is no word overlap. For instance, the system might miss the daughter, and the physician means the same thing. And this the lexical limitation lead to the need for the segmented understanding, and that's where the deep learning step in. The deep learning enhancement, the deep learning enhancement, the IR for the introducing the segmentic understanding instead of relying on these keywords. Neural networks can represent the words, phrases, and the entire documents as recent numerical vectors that capturing the meaning and the context. This allows the model to recognize the relationships like synonyms or the similar ideas even when phrased differently. Deep models can rank results not by the word overlapping, but by the meaning similarities. So users get the contextually relate with the answers instead of the matchings. And while coming to the next slide, uh, this slide is about why deep learning transformed the IR. The transformation came for the three core strengths, distributed representations and context and semantics, and the semantic ranking. While coming to the distributed representation, instead of the phrase word counting, words are encoded into dense vectors that carry semantic meaning, context, and semantics. Uh, the model like Burp can understand that the bank can be a financial institute or on the based on the context. This is an example for that, and semantic ranking. These systems can now prioritize the document based on the intent rather than the keyword frequency. These capabilities allows the IR systems to understand language almost like humans do. And while coming to the next slide, this slide is about the core deep learning techniques. Let's look at the main architecture that powering the modern IR. Uh, Welcome to there are three. three things that the word embedding and neural networks and the matching the networks. Modern models like word to vector, and the other GeoLWAR learn relationships. And while coming to the neural networks, CNNs and the RNNs and transformers, text across words and the captures deeper patterns, and the matching the network visual decoding models that match the queries and the documentation into the same vector space. This makes it possible to calculate the semantic similarities using the simple mathematical operations like percent similarities, etc. And together, these models powered together today, semantic and neural search engines. This is about the core deep learning techniques. And by coming to the next slide, the dense retrieval semantic search at the scale. The dense retrieval is a key breakthrough in the deep learning based on IR in the sense information retrieval. Here is the both the query and the document that are encoded as the dense vector within the shared high-dimensional space. And here is the work visual encoder network is trying so the relevant queries and the document pair are the close together in this space while irrelevant ones go far away. Training often uses the triplet loss, where the system learns to put the relevant pair closest to pair and they push the others away. This approach enables the segment matching and the retrieving the conceptual related results even if the words are different. The model like DPR means dense pass retrieval, and the Colbert have the state of the art results that open domain the questions have been answering based on the task that they have. And by coming to the next slide, the reinforcement learning for the query augmentation. There are the the reinforcement learning is now being applied to improve the IR performance, especially in the query reformation, reformations. The system like a deep retrieval starts with an initial user queries and it generates the multiple reformations. Uh, it then uses the retrieval recalls as a reward signal, and it keeps the best performing reformations over the time, and the models learn how to rewrite the queries for maximum retrieval effectiveness and the all without needed the need of the label data. And this method is has the achieved the state of calls in the fields like medical research and clinical trial discovery. While coming to the next slide, the applications of the deep learning in VR. Deep learning that powered our systems are now wide, uh, now across the industry. There are some like in the web and enterprise search and the questioning and answering. and in the medical research and the multimedia retrieval. Well, coming to the web and enterprise search, Google and the corporate search tools uses the neural embeddings for the smarter ranking and the question answering that the models retrieves the exact answers from the large knowledge bases. And while coming to the medical research, there the system finds the relevant clinical trials and the patient's data quickly. And in the multimedia retrieval that combines the image, text, and videos, understanding through the multimodal embeddings. In short, the deep learning has made the retrieval systems more intelligent, contextual, and the domain adaptive. This is about the applications of the data mine, deep learning in IR. While coming to the challenges and the future directions, and despite major process sort of challenges remaining, well, there are four data requirements and segmentic lexical balance, explainability, RAG integration. While coming to the data requirements, deep models often need the large labeled data sets to perform well. While coming to the semantic lexical balance, sometimes the meaning for based on the model mix the uh, important keyword matches. While coming to the explainability, the understanding of the model, why a model ranks the certain results higher remaining was a research problem. And for that, and the next thing is uh, RAG integration. In the future lies in the combination of retrieval with the generation. For example, retrieval augmented generation uses the LLM like ChatGPT to overcome these challenges that will define the next evolution of fire. Well, coming to the next slide. Uh, this the slide about the semantic search versus keyword search. Let's compare keyword search and the semantic search with real-time examples. Yes, a traditional keyword search for the best practices, disease predictions, name is the document discussing optimal health strategies, but yeah, semantic search models can understand that they both express the same intent and the retaining the relevant results regarding less of the exact wording. This shows the how deep learning allows the system to understand the intent rather than just the text, resulting in the better user experience and the accuracy. While coming to the next slide, the future of the IR. The future of the information retrieval is an intelligent, semantic, and the explainable. It is the smarter, faster, and more contextual. There are three for now: intent understanding, reinforcer learning, and next generation of IR. While coming to the intent understanding, the systems will continue improving at the grasping user intent. While coming to the reinforcement learning, in the reinforcement learning, the model will simply improve using the interactions and the feedbacks. While coming to the next generation of IA, the retrieval will be deeply integrated with the LLMs and for the contextual than the personalized answers. The it will move towards the systems that can understand reasons and generate the non-just retrieval. It generates using the LLMs. In short, deep learning has turned search into the understanding. And while coming to the conclusion, the deep learning has completely transformed the information retrieval, that shifting from the keyword-based searching to the through semantics understanding. It enables the smarter, faster, and the more context-aware systems that brings us closer to human level information understanding. Thanks for the opportunity. Thank you very much.